So yeah, we're going to talk about PaaS on Kubernetes today. First, a little bit about me. I'm the creator and CTO of Deus, which we're obviously gonna show, and you guys are gonna learn more about here. Little known fact: I was actually one of the largest external contributors to the Docker project during its formative months. So if you ever use things like the volume subsystem or the -v flag or bind mounts, or looked at a thing called host config, those were all things that we added into the Docker project in the early days to get early versions of Deus working. Also, as one of the first projects to use CoreOS and etcd for sort of this platform use case, we ended up in production with a lot of the stuff early, and therefore helped shape a lot of operational best practices around CoreOS and etcd. So Deus was acquired by EngineYard in April of 2015. We are a leading open source platform as a service. We now, according to Docker Hub, have 5.7 million downloads of version 1 of Deus. This is the pre-Kubernetes version. And sort of generally what we're doing is we're building products for the Kubernetes ecosystem. We're going to talk about Workflow today, which is sort of the traditional Heroku-style platform as a service layer. But also projects like Helm, which is the package manager for Kubernetes, and a few other projects in this sort of space, really answering the question, I have Kubernetes, now what? What we found in the wild is that Kubernetes is a cluster manager. It's got a lot of rough edges, and there's quite a distance to go from being having a Kubernetes cluster to actually getting work done as a software team, and we're trying to fill in those gaps. So, generally the mission for us is to accelerate this transformation to what is starting to be called cloud native computing. Part of this is about empowering developers, being able to create applications, deploy code, configure environments, view logs when your app 500s, scale out via the process model for 12-factor apps and more than that. This is really important to this idea of developer self-service is really important. So we're trying to empower developers through that. But we're also trying to empower operators. And I find this idea of this cloud native operational model really quite interesting. So this is how Google runs operations inside of Google. So they have some experience with managing distributed systems and platforms at scale. What they've done is they've taken the traditional operator job, for someone in DevOps, and they've actually segmented it into 3 areas. So you have infrastructure ops, which is hardware, racking and stacking gear, that sort of thing. Which is, by the way, sort of made obsolete by the whole invention of IaaS, right? You don't typically need to do this job. Google does it because they have custom hardware, other reasons. And then you have cluster ops, right? Which is this idea that you're taking nodes in lots of different racks inside a data center or in public cloud, and you're tying those nodes into this concept of a cluster. Right, and that cluster is tolerant of nodes coming into and out of existence, failures, that sort of thing. And there's a group of people who are good at this, and their job is to expose a set of cluster APIs up to another separate operations function, which is application ops, inside of Google known as SREs, Site Reliability Engineers. And these are operations people who are intimately familiar with the type of workloads that they're operating at scale. So, for example, dealing with all the monitoring and telemetry data that come out of apps, that's a very distinct job, and it's actually quite different than what you need to operate a Borg cluster or a Kubernetes cluster at scale. Those are different skill sets, different sort of conceptual problems, and wildly different from the type of infrastructure ops that most people are dealing with. And yet, if you think about folks today, the typical DevOps role, it's everything from provisioning boxes all the way up through gluing them together with some tooling, and all the way up through loading apps and workloads on them and managing those workloads. So kind of asking a little too much. So trying to move the world a little bit closer, inch by inch, towards this model, something that we do. So talk quickly about cloud native. So not sure if you found out about this Cloud Native Computing Foundation, but it's a pretty interesting group. I know a lot of people are like, oh yay, another foundation, wonderful, right? But this one feels a little interesting to me. It's for folks who want a new world for these born in the cloud applications. And interestingly, Cloud Foundry Foundation is a founding member of this, as well as folks like Google and many of Docker and many of the other big names in the space. So what is a cloud native application, right? The CNCF defines it very specifically. It's container packaged, dynamically scheduled, microservice based, right? Now, inside of the CNCF, they're trying to deal with all these different bits and pieces that are required to make distributed systems like this work. If you look at this diagram, everything in blue is sort of still being decided, right? Winners and losers are being shaken out in sort of the market of open source. So a lot of stuff needs to solidify before the CNCF is going to be complete in this mission of trying to make this more stable and interoperable. Another goal of CNCF, if you think sort of forward thinking, is where does a microservice architecture end up leading you, right? There's this idea of composite microservices, which are microservices that are constructed of other microservices and other composite microservices, and there's sort of a dependency graph that forms where a change in one service may actually end up impacting a series of other services, and having that modeled starts to become pretty important when you're deploying on these clusters at scale. Another thing very forward thinking is the future of publication and deployment. Our chief architect has this phrase that I like a lot, which is modern applications that are cloud native are sufficiently complicated that they need to be flown by the instruments, which is to say that really the monitoring and telemetry coming off those applications should be informing you of how you're supposed to handle these. So things like roll forward, roll backs, this idea of changes in a dependency graph that propagate automatically. This is the future that we're all building towards, and we're clearly not there yet, but having some of these primitives worked out and having the goals in mind is pretty important. The CNCF is taking the approach of sort of an incubator model for different technologies, and the first one that they chose was Kubernetes, which was offered up as the seed technology, and just a few weeks ago was accepted into the CNCF as sort of a donated technology. Now, that doesn't mean that CNCF is mandating Kubernetes. They're saying this is part of the toolkit for the future of cloud-native applications, and we expect there to be lots more projects donated in the future. So, quickly about Kubernetes. How many of you here have heard about Kubernetes? Yeah, so, okay, basically every hand. All right, well, that's good. The real idea here for Kubernetes is about managing applications and not machines. It's an API designed for cluster management, and otherwise known as Cluster Manager. So the 10,000-foot view is you have users talking to the Kubernetes master, which is made up of these different components, which talk to these kubelets that run on different nodes. But all either platform builders or users need to care about is that there's an API that they talk to, either via kube control or via an API client. And that talks to this big cluster of containers. And that's really all you need to care about. Now, the real question going forward is how leaky is that abstraction there, right? Do you actually just get to care about running stuff across hosts in any, running any OS or on any public cloud? I think there's a fair point that the abstraction is still a little bit leaky today. But the bet is that over time, this API is really going to hold, that abstraction is going to hold. And no matter where, whether you're running on public cloud, bare metal, private cloud, any OS, the Kubernetes API is going to be in the same thing. So real world adoption, this slide is actually pretty old, and there's a few big name customers that we're working with that we can't talk about that are actually on this slide. This stuff is being adopted like crazy right now. So if you just take a look at the activity in the GitHub project, it's pretty clear that that's happening. So why Kubernetes for us? Well, it's got this vibrant community, which is just crazy if you look at the GitHub project and growth stats. The idea of declarative APIs, everything in Kubernetes is, I want the cluster to have this desired state, and then the cluster reconciles that desired state in a series of control loops, and that's the entire architecture of how the platform works. It's very beautiful, it's very elegant, and it's really what you want for large-scale distributed systems. We believe it has these right abstractions, though there are many of them and they're complicated. But it also promotes loose coupling. The idea of labeling inside Kubernetes is very unique. You don't see that sort of thing in other cluster managers today. And to us and to me specifically, this really does represent Google's 10 years experience using containers at scale. There's a lot of lessons learned that went into the design of Kubernetes. And frankly, a lot of things that they did differently than they did in Borg, they did them differently in Kubernetes. Problem. Using Kubernetes is really complicated, specifically for developers. For operators and people who have our heads in this, day in, day out, it's, we can get it, we live and breathe this stuff. For devs, your average enterprise Java shop, they don't get this. They don't want to know what a replication controller is. They don't want to understand label selectors. This is just way out of their depth, right? So that's why we at Deus choose to build things like Deus Workflow, which is a private PaaS running on your own infrastructure. It really provides this simple developer experience. It looks a lot like Heroku or something like Cloud Foundry, but powered by Kubernetes and using all the primitives in Kubernetes and deploying things the right way so that applications in Kubernetes managed by Deus Workflow look and feel like any other application in Kubernetes. And really for us, this tool ends up being a force multiplier for operations teams. We don't see developers themselves, like developers go off the shelf, they'll pick up Docker, right, and start building Docker images and containers. The people who are picking up Deus Workflow are typically operators, right? They're operations teams who are like, I don't want to be in the business of trying to help my developers get their sandbox apps up and running. I just want to give them a space and let them run. And then if there's a pipeline that we need to create later, we'll worry about that later, right? And I'll show you a little bit about that. So Deus Workflow conceptually sits atop the Kubernetes APIs. We provide source to image builds, a lot like Heroku build packs, for example. Log aggregation, application release and rollback, authentication, authorization, very nice edge routing system that all sit on top of Kubernetes and leverage Kubernetes primitives where possible. So the workflow for developers is git push. I'll show you this in a minute. Git push, Deus PS, scale out the web containers. It's sort of this imperative, type in a series of commands, do a thing kind of model that made Docker very successful. But this is actually not how you drive Kubernetes at all, right? Kubernetes, you write manifests. You submit the manifest to the cluster. And that's great for a distributed system. And we use that declarative model under the hood. The problem is developers don't think that way. They don't want to write manifests. They want to say, do this, do that. Change this configuration, right? And having to submit a YAML change or a JSON change, is a little bit much for some folks. For operators, it's pretty simple. We leverage Kubernetes primitives, right? kubectl and a new project called Helm, which I'll talk about in a minute. So I'll talk about now. Helm. Best way to find, share, and use software built for Kubernetes. So it was interesting for us. When we started working with Kubernetes day in, day out, we were like, wow, it's really hard. You got to write these manifests and you got to find Docker images that work with different things. We wanted to make it really easy to get up and running with common workloads, define new workloads, and collaborate with the team on workload definitions in sort of the context of source control. And we created a project called Helm to do this, and it was a pretty, folks really agree that it was a problem space that needed to be solved for sure. And we ended up joining forces with the folks at Google on their deployment manager project, and are in the midst of joining Helm and deployment manager into a new project, also called Helm, that lives at Kubernetes/Helm and is now part of the CNCF. So Helm versus workflow, right? Why would you choose one versus the other? Well, workflow is really focused on 12-factor applications. We have a really streamlined experience for developers who are comfortable riding within those boundaries of 12-factor. But there's also lots of non-12-factor apps, and not just the databases, queues, caches, things like that, but anything that needs to swing a volume around inside a cluster, right? Deus components itself, right? We have a data store. Guess what? We use Helm to install and manage Deus. So that was actually part of the reason that we had for building it. So demo time. What I'm going to show you here is we're going to kind of run this demo in reverse. What I'm going to do is I'm going to show you the running thing, and we'll deploy some apps to it. I'll show you the different workflows, and then I'll uninstall it and show you guys a little bit more of Helm if we have some time. So what are we looking at here, right? So what this is a kubectl get of all the pods, services, replication controllers in the Deus namespace. Now, this isn't a talk on Kubernetes, so if you don't know what services, pods, and replication controllers are, you're going to have to pretend you do for a minute, because that talk's a lot longer. But what you can see here are the running containers, essentially, for our source to image builder, our controller, which is our API surface, a database, which backs the controller, happens to be Postgres, Minio, which is a really cool Go-based object storage system. The registry is just pretty much an off-the-shelf Docker registry. Our router, which is an Nginx router mesh powered by Kubernetes annotations and in some interesting ways. And a project called Workflow Manager, which is for helping with the upgrade process and versioning and assistance like that. We also show the services and their internal cluster IPs and sort of the desired and current state of the different bits here. So what I'll do is I'm going to jump into an example app directory. So this is, it's a little bigger. This is an example Go app. And what this is going to print is, where's the line here? Powered by some variable, which is going to be essentially an environment variable or the string Deus. So here's how this works for developers. If I do a Deus who am I, you can see with the Deus CLI, I'm currently logged into a Deus cluster at deus.gabbertv.io. So I can type in Deus create, go is the name of my app. And it's going to add a git remote, and then I'm going to do a git push Deus master. And what this is going to do is this is going to send the git contents of the git tree into the server side. That's going to take the git receive pack. It's going to unpack it. It's going to run it through a build pack, which is going to spit out a slug, which is 2.2 megabytes. And then it's going to upload that thing to object storage, and then it's going to basically create a Docker container that it can inject, that's going to be able to run that slug. And then it's going to orchestrate running a single instance of that container, which is kind of the default behavior. Now that all happened pretty fast there. I mean, I don't know how fast that was, but if we curl go.gabbertv.io, which is my cluster name, we can see powered by Deus on release v2. Now what actually happened there? This is a command, kubectl get PaaS services and replication controllers for the namespace Go. So what happened was when I hit Deus create Go, behind the scenes we created a Kubernetes namespace for the application because that's best practice. It is to have logical separation for your application and by namespace. And we also created a service, that 10.3.0.130, exposing port 80 for this HTTP-based service. We assume services deployed via Deus Workflow are HTTP-based stateless 12-factor services, so we can make that assumption. Now that we've deployed this thing, we actually have a replication controller, which is version 2 of the app. We're asking for one of these. And you can see up at the top the one running pod with the readiness checks passing. So everything's working, and this is what sort of it looks like natively inside Kubernetes. Now, if I want to scale this out, and I'm a developer, I think in terms of this, Deus scale web equals 4. I don't want to have to write a manifest and resubmit the manifest, though you could. Now what happened was, in 4 seconds, that command returned, and we now have 4 running versions of this app, all of which are passing health checks, and everything is fine and dandy. So now, what happens when, this is a very default example, what happens when we want to change some configuration? Well, we use this config set command to pass environment variables, which are how we handle configuration inside of 12-factor. So what we can see here, if we flip back over to this, is we're going to start rolling out version 3 of this web application, and it's not until the new versions are in service that we can actually remove the old version. Otherwise, it's not a zero downtime deployment, right? So you can see here we are, well, it happened already. So that was 4 containers were replaced fairly quickly there. If we curl this again, because we are reading from that environment variable, you can see we're powered by Kubernetes. If I hit it a couple times, you can see the pod IDs are changing. We're balancing across the different pods there. We're also managing this release ledger, right? Deus releases is this sort of monotonically incrementing ledger of different changes made to the application, so you can know who on your team did what and when. And this is extremely useful in the world of platforms. The fact that I deployed a given SHA at a certain point is really nice from the standpoint of a dev environment. So I'm going to quickly show you some other examples here. So we're going to do a Deus create on a Docker file application. This particular application has a Docker file that looks like this. From Alpine Linux, powered by Deus, sort of the same kind of deal. So let's git push this thing. I apologize, there's a little bit of debug output in this. This is actually a beta release at the moment. But what this is going to do is this is going to build the application not using a build pack like the first example, but it's going to build it using a Docker file. And while this is going, I want to talk to you a little bit about philosophy we have with regard to the build stage of these applications that we like to refer to as crawl, walk, run. So oftentimes, developers who are approaching this stuff don't want to learn how to build an application. They just want the damn thing to work. And so build packs are great for that because as long as you follow convention about how you lay out the files on your file system inside of the repo, build packs just work, and you can just make everything just fly, right? Now, what will happen inevitably is you're going to need libxml version something that's not in the base image of what the build pack is using, or you're going to need to customize the userland execution environment in some way that build packs don't work with. That's the point at which it's probably going to make sense for you to start writing Docker files from scratch, right? And so you take a look at this Docker file. This is how you're going to get that custom version of libxslt or whatever it is that you needed into your application. Now, note that with this model, though, you're still Git pushing into the cluster, right? The developer is, kind of deving on their laptop. It's kind of a dev in the cloud sort of environment where you dev on your laptop, you Git push, you see the thing running in the cloud attached to all the cloud-based services that you need to attach to. Now, at a certain point, it's going to make a lot more sense rather than having someone Git push this thing into the cluster every single time and have it rebuild an image every single time. You're actually going to have CI, your CI system, start building some of these images, right? And that's so build packs are crawl, and this is walk. The Docker image workflow is run. So what I'll show you here is we will Deus create some random app namespace. It errored out because it's not a Git directory, but Wilder tabletop. And so what I'm going to do is I'm going to go to do a Deus pull, Deus/example go :latest for the app Wilder tabletop. And what this is doing is this is actually taking a pre-built Docker image, could have been built out of CI, this one happens to reside on Docker Hub. And what it did is it promoted that directly into the applications space here. So if I curl wilder tabletop.gabtv.io, you can see powered by Deus, which is just some Docker file. And this really makes for a really nice transition for folks who are looking to get up and running in this new world, but for whatever reason don't want to learn Docker, they don't want to learn how to do this stuff, and really solving this problem for operators of, okay, I stood up this big cluster, now how do I let my developers use it without having to give them 4 weeks of training like they have to do inside of Google, right? Cool. So that's that. Any questions about, well, you know what, I'll save questions for the end. Let me just show you quickly how we uninstall and reinstall this platform using Helm while I'm at the command terminal. So I'm going to Helm uninstall. Actually, I'll show you a Helm search first. So by typing in Helm search, actually Helm up, just to update charts. This currently uses a brew model backed by GitHub repos. I have, if I do a Helm repo list, you can see that I have 2 different repos. The canonical Helm charts, which is maintained by the community, has lots of different stuff in it. And then I have another repo called the Deus/charts repo. Charts are the unit of, as you call it, a template for a Kubernetes application or workload. And if I do a Helm search, I can just get a list of every single thing. You'll notice that the Deus/stuff is the things in the Deus charts repo. There's a little bit of namespacing going on there. But there's all this stuff available, people added Spark and Storm and different things that run on top of Kubernetes. Quite interesting. But the Deus Workflow -beta 2 is what I'm currently using. So if I do a Helm uninstall workflow-beta 1 -ndeus, you have to specify the namespace you want to put the things into or uninstall from. I can uninstall all the objects. And we flip back over to the view of the Deus namespace. What you'll start to see in a minute here is everything pop out of existence. We begin by deleting some services. So you'll see the services start to slowly disappear. But this is also the inverse of this is how we stand the platform up. And once everything passes the readiness checks and the liveness probes inside of Kubernetes, you're up and running. So really, if you have a Kubernetes cluster, you can go from Kubernetes to full-blown Deus-powered, Deus Workflow-powered platform as a service in, about 2 minutes. Which is a pretty compelling story. Granted, standing up the Kubernetes cluster might take you a little longer if you're not on something like Google's container engine, but it's still a breeze compared to a lot of the other ways it takes to set up a platform. So Great. Well, that was what I wanted to show on the demo side. In terms of this is, by the way, a beta that I was showing you. This is beta 1. We just released it on March 25th. We have these 2-week sprints that we're doing, operator UX, stability, and monitoring. Each are going to produce a beta out of those, and we're going to have a release candidate targeted for May 25th, and stable should come out on June 8th going forward. One of the reasons why we're fairly confident in these numbers is the beta that you've seen is actually quite stable, in large part due to the fact that Kubernetes itself is just such a rock solid engine that this is probably at this point an order of magnitude more stable than what we had in the version 1, which was powered by Fleet and etcd directly. And also the beta 1 is feature complete, or mostly feature complete, so there's very little that we're adding in the way of new features. It's all around sort of stability and operator UX. So after that, a couple things we're working on. One is a Deus Doctor, easy way to submit issues if you are having trouble. We found it's, we're very focused on sort of community engagement and making sure that the open source community and people who want to use this for free can engage with us really well. So we want to build some tooling to allow people to report issues. That's what Deus Doctor is. We do have a number of very large customers, and for those folks, getting more granular control over teams, permissions, authentication, bridging that with enterprise authentication authorization story is extremely important. So we've done some work there. And a service broker. I'm actually a big fan of the Cloud Foundry Service Broker APIs. And so what we're doing is we're taking those APIs and we're applying them to the world of Kubernetes. Because a lot of people don't want to run everything inside the cluster manager, right? They don't want their databases necessarily running inside the cluster. Maybe if you're on Amazon, you might want to take use of, or on Google for that matter, you might want to take use of BigQuery, right? Which is not something that you're going to run inside of Kubernetes, right? Most likely. So being able to bridge not just to services that are non-12 factor that reside in your cluster, but more importantly, bridge to services that are provided by a cloud provider, and connect those two worlds between the workflow powered apps and the ones that are provided by a cloud provider, extremely important. And that's some of the work we're doing with Service Broker. Past that, private registry support is really important. There's more we can do there. We've gotten a lot of demand for private, non-routable applications. You can do this kind of behind the scenes today, but we can make this experience smoother. And then, tracking the Kubernetes APIs. One of the things that is sort of different about our approach versus some of the other folks who operate in the Kubernetes space is we wait for features to fully bake inside Kubernetes before we adopt them. And because of that, there's always new stuff getting rolled into Kubernetes because it's improving so fast. So we have to, as a open source software team, we have to put in cycles to get up to speed with the latest best practices in Kubernetes. And the way we look at that is we're really doing that on behalf of our users, who are these DevOps folks inside of typically large enterprise. So with that, I want to mention that we do have an open planning process that I'm actually quite proud of. It's something we've been doing for many, many months. We have, typically we release the first Tuesday of every month, and then the first Thursday of every month, we have a community meeting, online, a face-to-face sort of meeting, and talk openly about what the roadmap, where we're going, and solicit feedback from the community. So we don't take decisions in private where we can avoid it. So that's that. Any questions? First person to ask a question gets a T-shirt. I feel like you have to have some incentive here for an audience that's quiet. Yeah, go ahead.
Does having sort of SSH and Git running on your kind of main server there present any expanded security concerns about having that running like that?
So the question was, does having SSH and Git on the server introduce a security problem? I think the bigger security problem is building images on cluster generally requires access to mount overlay file systems and things like that, so the containers have to run privileged. The actual code for the SSH server is all custom Go-based SSH. We don't actually run OpenSSH, that sort of thing. So it's the SSH server itself is pretty, like any other controlled user land container. The mounting of the Docker socket. There's a way you can build in cluster, or build in cluster without having to mount the Docker socket, but it's a little tricky. Yeah.
You run it in the container anyway, right?
Well, yeah, all this stuff runs in containers anyway, so it's secure, right, by default, right? Yes? Pros and cons of Deus versus Cloud Foundry. That's an interesting one. So, I think that I would say the first thing I would say is a difference in philosophical approach. So with Deus, what we're trying to do is we're trying to take a cluster manager like Kubernetes and add a platform layer to it, right? Or lots of different things to it. Cloud Foundry is a big stack of stuff that does everything from VM management all the way, up through what I'm showing you here at the platform layer. I actually have a lot of respect for the folks who originally built Cloud Foundry, because that's a really difficult thing to do, to have all of that overhead, to have to manage all that, everything from the scheduler to, the routing and VM management, all that stuff. We have taken an approach that says, as technology matures, it tends to mature from the ground up, right? So what you saw was like the IaaS layer starting over time to ossify and get more stable. And then there was this other layer called the cluster manager layer, which who knew existed? So it's things like Mesos and Kubernetes and things like Diego inside of Cloud Foundry. We're starting to see that layer now ossify, and so what we're interested in doing is trying to focus as much as we can on the platform experience and less on the underlying plumbing, and let kind of that get solved by this sort of standardization and ossification being spearheaded by the CNCF.
Could you explain a little bit about sort of multi-tenancy and isolation of either applications or organizational multi-tenancy?
Yeah, so multi-tenancy is a good question. What we found in the field is that a lot of people have a different definition of multi-tenancy. Some think of it as like, this is developer self-service, right? So each developer is their own tenant on the system, and so we want isolation between tenants. Some people think about tenants as divisions inside of a company. Other people think about tenants as like different untrusted actors like you might find in a public PaaS environment. So it depends on your definition of multi-tenancy. In terms of the security concerns, they've generally fall into two categories. One is at the runtime level, so like sort of the Docker container and sort of the OS execution layer. We feel like with things like seccomp being added to the Docker engine, and syscall filtering and sort of the general container security stuff, that the runtime level is getting pretty buttoned up. Image management and what are you running in terms of the code, that's a much trickier problem, but if you have a controlled build pipeline and a controlled build process, you can mitigate that pretty effectively. Now, the other side of this is the networking side, and the networking side is pretty complicated at this point. There are a ton of vendors in the space. I just came here from a meeting with the good folks at Weaveworks, where this was basically the entire topic of conversation: is how can we as a community better solve what's referred to in the industry as microsegmentation, or the ability to separate container networking based on policy. Lots of other folks in the space tackling this as well. The SIG networking group. SIGs are special interest groups inside of the Kubernetes community that tackle different problems. They recently came out with a proposal for how to use labeling to enforce fine-grained network access controls. So what I would say is networking is an unsolved problem as of this minute in terms of network security inside a Kubernetes cluster. So separating on tenants, either you trust them or you don't, is what I would say. Going forward, I expect that to be solved, and I do not expect the runtime component to be a blocker on that. Other questions? No? All right, great. Well, I'll be around for a little bit, so if you have a question and you're a little shy, feel free to find me afterward. Otherwise, thanks everyone for coming.